dx. So I have everything I need in this problem to be able to now take the antiderivative of it. This would turn into the integral of 2 dx turns into du over u. And we have that note card today. We've just learned that integration. This would turn into ln of absolute value of u plus c. So that means this final answer would be ln of absolute value of 2x plus 5 plus c. Easy enough. Try this one on your own then.
Oh,
I'm not ready for trig yet.
Is trig today or tomorrow?
I didn't put any trig examples in today.
Thank God.
Well, you move it down a little so I can take a picture.
Because it's Monday. So.
There we go.
Okay, so try this one.
Do you have to leave a substitution? Can you just like?
You're thinking through the u substitution without writing it down.
Yeah, like can
Yeah.
you just pick out the bottom?
Yeah.
And just like, is that gonna work for like almost?
For these very simple ones, yes.
Okay, very good.
It will get a little more complicated, yeah. So are you done? Yes, because your u was this.
Hold up, I'm still writing. I'll write too fast. Alright, I'm good.
So
Yeah.
it's just ln of 3x squared plus 1
Yeah.
In the absolute value,
plus c.
and then plus c. Because this does turn into the integral of du over u. Is the absolute value absolutely required here? Because what's true about 3x squared plus 1? It's always positive anyway. So could you leave off that absolute value?
Mm-hmm.
Yes. If you did leave off that absolute value, though, what symbols would you need to use to make sure that you remember the 3x squared plus 1 is your argument? Parentheses. So you could change this over to this. But you'd have to use some kind of grouping symbol to keep the 3x squared plus 1 all as the argument that you're taking the natural log of. Okay? Oh, I guess I spoke too soon.
Oh my goodness. Thank God.
Thank God.
Sorry.
Lied to us.
Yeah, it was unintentional. Sorry.
That's alright. Where is your integrity? Ln of sin of x.
What would you think about using for a u?
Son of a-
Okay, so just keep this in mind. Do I ever want du in the denominator?
No.
No. So that helps you sometimes to pick out what your u value would be. So if you let u be sine of x, du would be cosine of x. So isn't this is the antiderivative of du over u, which would be ln of
Alright, this is getting kind of simple. So how's it get harder?
Just wait.
I'll show you one where that gets a little bit more difficult. We're getting there.
We could just live in this.
Yeah.
Live in it now.
This one's not going to be. I'm sorry, there's not a 4 here. This is just 5 minus x to the 4th.
Well, that's no fun.
Like with.
Okay. So we're just going to see another problem where you have to introduce some constant values. What is your u? 5 minus x to the 4th. Our du. So do we have that factor of -4?
You're gonna multiply
We're
that
gonna
in,
introduce it, multiply it in, and then also
divide it out.
turn around and divide it out. So then this would really turn into the integral of
Negative du over 4u.
negative du over 4u. Yes, so it's like a coefficient of -1/4 out front. So then this would turn into -1/4 ln of the absolute value of 5 minus x to the 4th plus c. So Josh, it gets more complicated when we throw in other fractions that aren't really Lin
Mhm.
integrals, or it's not obvious that maybe you have to factor something. It may not be written exactly as simple as this. So it just gets more complicated when we change the form of the integrand, or we throw fractions in there that aren't
Yeah.
really Lin. So let's look at example 5.
So is this gonna be like a short lesson? Because we're going through this kind of fast.
Yes, sir.
And then we're just gonna work on it?
Plenty of time to practice this. I have a classwork assignment and a homework assignment for you to practice this today.
All right.
Okay, so how about this? The integral of 5 minus x to the 4th over x cubed. Does this even have to be a u substitution problem? No, because can't you separate this into 2 fractions and write it using exponents?
Oh, yeah.
Doesn't this integrand turn into 5 over x cubed minus x to the 4th over x cubed?
Yeah, it'd just be
So then that would really just be the integral of,
5x negative 3.
yes,
And then minus x.
there you go. So now can you just integrate each one of those parts using your exponent rule? Add 1 to this exponent, and what do you get?
Negative 5 over 2x squared.
And then minus,
Negative x over x squared over 2, yeah.
is this one where we would want to separate it into different fractions and try the exponent rule? No? It does not separate nice and neatly. So, any suggestions?
Make the bottom u.
Try letting the bottom be u. And then du would be,
2x minus.
2x minus 1.
So you can just multiply the top and bottom by 2.
couldn't I multiply this entire numerator by 2? Now wouldn't that match my du?
You got multiply the denominator.
Make sure you multiply that denominator by 2 also. So then doesn't this change into 1/2
du over
du over u?
So is that just 1/2 ln of the bottom?
1/2 ln of what our u value was, plus c. Now let's change it up just a little bit. How about if I keep the numerator as x minus 2, set the denominator as x squared minus 4x plus 6, all quantity squared. So what would you think about for your u?
Still the bottom.
and b x squared minus 4x plus 6.
Correct? Then about our du? Yeah, that. So, is this gonna work for u substitution? Oh wait, we need this here, make sure you got that. Yeah, put that factor of 2 back in, correct? So 2 here, 2 there. Now, yeah, when you rewrite it, what do you think, Bennett?
1/2 du over u squared.
Du over u squared, very nice. So couldn't I now rewrite that as 1/2 u to the negative 2 du?
You integrate that?
Now you can integrate that just using your exponent rules. Add 1 to the exponent, u to the negative 1, divide by negative 1 gives us negative 1/2 plus c. Now you would just go back and change that,
So negative 1/2 ln
and I'm gonna go ahead and move this to the denominator. X squared minus 4x plus 6.
Oh wait, no, it's not.
Josh, will you stop that recording for me?
Don't you need to